right, for this video, we are going to be talking about converting improper fractions into mixed numbers. I didn't put that in the title because it was getting a little long, but you can see it says right there in the directions that we are converting them to mixed numbers. Now, just a reminder, improper fractions are where the top number is bigger than the bottom number. So the numerator is bigger than the denominator. I like to remember that as the denominator is down. Mixed numbers are where I have a whole number included. So 2 and 1/2. Those two are equal, just the same way of writing different things. So I have like 2 wholes and then also another half pizza or whatever it is. This one I'm just thinking about them as individual halves, and I have 5 halves. Notice how the pictures look the same. We're just thinking about it as pieces versus wholes. I'll show you some more examples. And for this, I'm actually going to do some of the problems from your worksheet. I know there's 20 and that's a lot, so I will help you do some of them. And I'll show you some different strategies to do that. So I'm going to actually start with number 2 here, 11/10, because I can do it on the fraction strips, and I want to show you what it looks like. So if I go to the fraction strips, so it was 11/10. So I'm going to go ahead and just put 11/10 on here. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so I have 11/10, right? Well, now I want to think about how could I group those into one whole. Well, if I put the whole right here, I can see, oh look, 10 of them are equal to one whole. 10/10 equals one whole, and then I just have one more 10th left over, so that equals 1 plus my 1/10. So on my sheet, that's 1 and 1/10. You can write it here, you can write it here, you can write it on both. Now here, 27ths, I can't use the fraction strips for that, but if I thought about it, oops, wrong thing, sorry. 27ths, what if I think about, okay, here is, let's say that call this a 7th. How many 7ths do I need to have to equal one whole? How many 7ths equal one whole? Well, 7 7ths. So 2, 3, 4, 5, 6, 7. That's one whole. Now I still have, if I do 20 minus 7, I still have 13 7ths left. So I could do another 7 7ths to get me another whole. So if I take away 7, now I have 6 7ths left over. So that's less than one whole. I can't take out another whole. So I have one whole, 2 wholes, plus another 6 7ths. So I have 2 and 6 7ths there. I can get 2 wholes out, if you will. Again, so 6/4, I could go use my fraction strips, drag out 4ths, see how many wholes I can get. I could also, sorry, I was just gonna, that was 2 and 6. Okay, now 6/4. So if I just think about my pieces, I have 6 pieces, and I want to put them into groups of 4. Well, if I do one group of 4, I can't do another one, so here's my one whole, and then I still have 2/4 left over. So I have 1 and 2/4. I can just do division. So if I just do, for number 4, 13/4, well, how many times does 4 go into 13? Goes in 4, 8, 12, 3 times. 3 times 4 is 12. Subtract, I get 1. Now, this is my whole number. This is how many times 4 went in altogether. My remainder becomes my numerator, and my denominator of 4 is going to stay a denominator of 4. So that's sort of a shortcut way of doing it, especially if you get like 66 7ths. That's a big number to draw. Versus if I just can do it the shortcut way and get 3 1/4. Let me show you the division way again. If I have 66 divided by 7, because a fraction bar is just dividing. That's all it is. 7 goes into 66. Well, if I count by 7s, look at my multiples, look at my multiplication chart. 9 times. 9 times 7 is 63. Subtract, I get 3. 9 is my whole number. 3 is my numerator. 7 is my denominator. My denominator always stays the same. My remainder becomes my numerator. My my quotient becomes my whole number. Different strategies to figure it out. Long division is one way. So long division, there we go, that's what I meant to do. Long division is one way. Using those fraction strips works to a point, except when we get big numbers that wouldn't fit on there. Or you can always draw a picture and separate it into groups. Or you can think about sort of taking out wholes. And how many wholes can I take out? Let's do another smaller example. So say I hadn't gotten the 6/4 yet, and I wanted to use my fraction strips. So let me erase that there. I'll get rid of that. So we're talking about fourths. I figured out if you refresh it, it goes away if you don't want to drag them all off. So fourths, okay. So I have 1, 2, 3, 4, 5, 6. Okay, so now let's see. Ooh, that's one whole. And then look, if I do another whole, it doesn't fit up that whole thing. So I just have one whole there, and then I have 2 more fourths left over. That's one way I could get 1 2/4. Now with 86/8, that's not going to fit on here. I can't just drag 8s. I might be able to fit them all, but that's going to take me forever. Okay, it's not a great strategy for big numbers. Now for 7/2, you could probably fit 7/2 on there. For 14/5, you can probably fit that on your fraction strips. But some of the big numbers, you're going to want to use the long division strategy to help you. All right, clue word for today, starting a new sentence, is the word I. So just capital I. I is going to start the next sentence for your math secret code pathway. If you need more help, I'm more than happy to help. Just let me know.